Hi guys, this is CEO speaking again. It's time now to pass to the next step, meaning we're going to check our relays because anytime we want to use them, we have to be able to check the configuration of the relays and of course if they are functional. So let's start by establishing what's going to be the basic diagram for our relay use. Okay? So first thing, we're going to simply draw our relay. This is the body of the coil. Now these little protuberance going out of it is the end of the core of the coil, and we call this the yoke. And then the rest, which is actually a cylinder inside, we call this the iron core. Okay. And now here we figure the coil itself. So this is the coil. And here we are going to apply energy for the coil. We write it here, coil voltage. So far so good. In front of the yoke is going to be a metallical piece. In the moment the coil is energized, the core is going to become an electromagnet, so attracting it. This is going to be a moving part. We call this the armature. Okay? This is the armature. And linked to it is what we call the pole. Remember 2 videos ago? The pole is the moving part establishing the link between the common, normally open, normally closed. And at the end of the pole, we simply draw the contacts. This is the normally closed. This is the common. See? This is the normally open. So far, so good. And now, from each of them is going to be a wire coming out of the relay. One here. Another one here. And another one right here. So, the common is going to come together with this flexible part. And now, this is called normally closed because before we energize the relay, the common is touching it, and the other one is normally open because before we energize the relay, the common doesn't touch it. And here in the bottom, we're going to draw what we are going to connect to the contacts to make everything working. So here is going to be, we won't have a heavy load, we just have an LED, and together with the LED, we have a resistor. Anything between 300 ohms to 1 kilo ohm is good. So we put here a red LED. Okay? And this is going to go to the positive of the voltage. So the common goes to the positive of the voltage. Here, this one goes to the ground. On the other side, we have something similar. This is going to be a green LED, a resistor to the ground, same value, 300 ohms to 1 kilo ohm. Okay? How this is going to work? At the beginning, when the coil is not energized, here, through that resistor, and the diode, and through the normally closed and the common, we close the circuit here to the positive voltage. So the red LED goes on. What does it mean? The red LED says the relay is not energized yet. In the moment I energize the relay, the armature is going to be attracted to the core. This lever is going to go up, pushing the common to touch the normally open. So the normally open closes. So then we're going to energize the green LED. Okay? So we draw here the second situation when the relay is energized. Here is not energized. So coil not energized. And here is going to be coil energized. So here we're going to draw the contacts. This is the pole, and now the pole is pushing the common. This is still the normally open. The common is here, and the normally closed. So from here, we go right here. From the common, we go here. And from the normally open, we go right here. This is the flexible part. Okay. So now the pole pushed the common up to touch the normally open, which closes now. And we have the same circuits here. We have a diode. This is the resistor. I don't write the value anymore because you know it already. This is the red diode. This one goes to the positive voltage. And this one here is the other diode. LEDs, this is green. And going right here to the ground. So this time, when the coil is energized, the positive voltage coming here passes through the normally open, which is now closed, through the diode and back to the ground. So this is going to be the circuit. In some of the relay blocks, you can also find inside the relay, like in the big ones, like that one here, you can see in the top a red LED. So this is going to be connected permanently. Where is this connected? Something like that. Okay, so there is a resistor inside. It's 1 to 2 kilo ohms, 1 to 2 kilo ohms. And this is an LED. Just to show that as soon as the coil of the relay is energized, this LED pops up, so you know it's energized. And on some others, you're going to also find another diode, because some of the manufacturers, they want you to respect a certain polarity. This is going to be the positive, and this is going to be the negative. What kind of diode is this? Any from the series 1N, 4000, whatever, 1, 2, 3, up to 7, okay? So, for our little relays, the PCBs, we won't have this one and that one. But I'm just saying, I'm going to show you some other relays having these things inside, okay? So now we have the situation when the relay is not energized and the situation when it is energized. So I only drew the contacts here, okay, not the coil. Now, this is the circuit we're going to follow, and I'm going to put this in the comments, attached to the comments of the video, so you can download it anytime you want, okay? Now we put it here, because this is the one we're going to follow all the time. So now, let's go to work, okay? I'm going to start by using the big relay, the one we discussed 2 videos ago. I establish a kind of pattern here, just to make sure that anytime we want to watch the wiring is going to be the same. I established a kind of color code pattern. I'm using the orange for the common. I'm using the white for the normally closed contact, and the green for the normally open. So far so good. So for this one here, if I was picking up this particular relay, this is a 24-volt relay. So what do we need to focus on? Two things. The voltage we energize the relay, and then the configuration of the contacts. So this, I said, is 24. So first thing I do, I put my power supply on. By the way, this is an old power supply, a Hewlett-Packard one I salvaged from the yard, and I fixed it. It's working very well, so don't worry, you don't always need the latest power supply with digital displays and so on. Okay, I put it 24. For you to be more comfortable with the size of the voltage, it has to be any voltage between 10 to 24 actually. So it's shown here on the digital display just in case to mention it. Okay, so if I'm having less decimal, okay, so that's good enough, about 24 volts. And now what am I doing? In order to check the contacts, I pick up a group of contacts. What does it mean, a group of contacts? Exactly what we discussed here. One common, one normally closed, and one normally open, okay? So for that, I only need to use an ohmmeter. So then, I pick up my ohmmeter. So now, I connect one leg to the common, the other one to the normally closed, okay? So please notice that, do not be bothered by the internal resistance of the wiring. So now, I check the normally closed. Take a look, the relay is not even energized. But now I can read 0 ohms simply because you know the normally closed is touching the common. That's exactly what I'm measuring now. In the moment I'm going to energize, so for these big relays, this one, for instance, it has 8 contacts around, and between 2 and 7, which are right here, is going to be the coil. So I pick up from the power supply the 2 legs, and if I touch the 2 and 7, can you hear it? It's clicking, okay? Additionally, you can see the LED in the top saying the coil is energized. And if you watch the ohmmeter, from 0 ohms, now it goes to overload, which is infinite value, contact is open. So this is the normal situation, normally closed. Now it opens, okay? Now I'm checking the other one. The common remains where it is. And now I connect the normally open one. So normally open meaning what? Before I energize the coil, I have overload. As soon as I energize the coil, so I do the same. So for this relay, there is no polarity of the power supply. So even if I connect it like that, it's working fine. Or if I connect it opposite way, it's still going fine. Okay. So what does it mean? Normally open is open if you don't energize. As soon as you energize, it closes. See? So I check my relay. Not only I check the relay is good, but I check the group of 3 contacts to make sure I understand which is which. So I pick up this one, I put it aside. I don't need this one anymore. Now I pick up another one. So for this one here, I'm going to pick up a very simple configuration, this one. This one is still energized 24 volts. And unlike the other one, there is not a full group of contacts. There is only an incomplete group because it has the common, as you can see here, the pole is figured like the inclined line, and the normally open, which is the green, okay? So I do the same as before. I connect it here, over the ohmmeter, and as you can see, if the relay is not energized, the indication says overload or infinite value. 24 volts is still there, so now I can energize the relay. So if I energize the relay, you see, now the LED on the block, it says the relay is energized, and you can read 0 ohms, overload when it's not energized, 0 ohms when it is energized, okay? So I can check this one as well, but there is an incomplete group, okay? By the way, this one, take a look again. It says here in the top positive and negative. So I put the positive, the red, right here, and the negative on the other one. So everything is fine. But if I reverse and try to energize the opposite way, it doesn't work anymore. Why? Because of this particular diode placed right here, preventing the relay to be energized if I connect the negative here, because negative on the anode of the diode won't allow the current to pass, okay? So this has a diode, and you can see the diode is right here, that little diode from the series 4000, okay? Preventing the current to pass if you energize opposite way. So this is why the manufacturer said plus and minus, because they wanted us to respect a certain polarity, okay? Now, I'm picking up another one. I'm picking up a, let me see where I misplaced it. Just give me a second to find out, because it's going to be somewhere here. Right here. So I pick up this one now, because this one is exactly what I have here in the top, that configuration. And on all the industrial relays, you're going to find the notation A1, A2 for the two legs of the coil. Let's go back to the previous one we just checked. Take a look. A1, A2, A1, A2. Similarly here, A1, A2. So this is where I'm going to energize the coil. And this one is a 24 volt relay, exactly the same as before, 24 volt. And here are the contacts. Remember, I use for the common the orange, I use for the normally closed the white, and for the normally open the green. So now, I pick up this one and I put it aside just for a minute before I go back to it. Okay, okay, and now I pick up the new one and I check. Common is the orange. Take a look. Normally closed is the white. You see here, 0 ohms. The relay is not energized. When I'm going to energize the relay, remember it's still 24 volt. Never forget to check your voltage. I'm energizing it. Now it opens. It was closed. It opens now, okay? So it opens anytime I'm touching. And also the LED indicator right here. And this one has a resistor of 2 kilo ohms in series with the LED. There is always a protecting resistor in series with any diode. So now I connect my ohmmeter over the normally open contact to check it. Okay. So now I have it over the normally open contact. In the moment I'm going to energize my relay, zero ohms. Open circuit, so it shows overload, 0 ohms, okay? Because the relays we checked so far, we were checking only a full group of contacts. We don't need a special circuitry for that. The ohmmeter is just good enough, okay? Now for this one, if you remember the 2 videos ago, I said I can change this relay from here, and I can place, instead of this relay, which was 24 volt, I can place another relay. This one is a 5 volt coil relay, okay? So it has the same pin configuration as the white one. I mount it here, I protect it, but this one is 5-volt coil. So before I'm gonna be connecting everything, I have to put my power supply on 5-volt. So I go back on 5-volt. Anything close to 5-volt is good enough. Okay. So now I'm going to make the connections. Remember, still the same. The common is the orange. Normally closed is the white, and I check it here. The relay is though not the same. The relay now is a 5-volt one. Power supply on, and now I energize the relay. Take a look on the ohmmeter. When I energize the relay, it was normally closed, so from 0 ohms, it opens, overload. Okay? Opens, overload. Now I check the other one, the green. Okay. The green is the normally open one. So normally open means infinite value, overload. And now I energize. When I energize, it's going to close. And by the way, you can see the LED on the relay block is less bright than before, simply because the amperage goes much more, but still, with the protective resistor in series with the diode, you can still see the LED going on, okay? Good. So I was able now to check a 5-volt relay having the same configuration. What configuration? Exactly this one. So don't worry, I'm gonna put this documentation attached in the Google Drive, so you're gonna be able to download it. This was the block containing the initial 24-volt and now the 5-volt relay. I take it aside, I don't need it anymore, okay? Now I come back here. This one, the very flat one, the slim relay, okay? This one uses a finder relay, and this is a 12-volt, it's not a 24, it's not a 5. So before I do anything else, I adjust my power supply accordingly, okay? So I put it at 12. Anything close to 12 is good, okay? Now the power supply is okay. And now I have the same configuration here. You take a look. A1, A2 is the same notation, is an industrial relay. So A1, A2 are the two legs or the two ends of the coil. And here I have the common, orange, the normally closed, the white, and green, the normally open. So I'm going to check. I'm going to connect my red to the common. I'm going to connect the other one to the normally closed, and it shows, obviously, 0 ohms. And now when I'm going to pick my 12-volt power supply, and I'm going to energize, the LED of the relay block is right here in the top. Take a look. You can see the little LED in the top. So what happens to the contact? It goes open. It was closed. Now it opens. Closed, 0 ohms, opens, infinite value, overload, okay? And now I'm checking the other one. This was the normally closed. I'm connecting it over the normally open. So the normally open shows overload. And now, by connecting the power, it closes. So 0 ohms. Overload, 0 ohms, okay? But there's more. I can pick it up. Remember, that relay is 12-volt power supply. I put it aside, and I pick up now an identical shape of this one. Is an identical shape, but this one is 12-volt. Is 5-volt, sorry. Instead of 12, it's 5-volt. And it has the coil right here, and the group of 3 contacts right here. Unfortunately, I cannot check it on the breadboard, simply because if you take a look on the diagram, because I have the diagram over the second page, is right here in the top. it says the arrangement is known. However, the distance between these two terminals here, I left it here for you on purpose, is not the pitch of the 2.54 millimeter or 1/10 of an inch between the legs of the diode, of the legs of the coil, sorry, but it's 3.75. So if you really want to plug such a thing over a breadboard, you have to fold the terminals like this. I'm not advising you to do this because it's very risky. You risk to break one of the terminals. So this way, if you do, it may possibly fit on the breadboard, but again, you have to fold these two ones because otherwise it won't work. Instead, I will prefer to check it right here over the socket because it allows me to show you how the contacts are operating. But again, this is 5 volt. So before I'm connecting my power supply, I have to adjust it to 5. So any close to 5 is good. I don't waste the time with that. So now I'm still over the normally open contact, as you can see. So it's overload. And if I energize, I want you to still see the LED over the top. Even if the voltage is not 12 anymore, it's only 5. So it's a bit fading, but we can barely see it, okay? Because it has a big 2 kilo ohm resistor in series with it. Anyway, the contact was open, now it closed. Open or overload, and now it closed, okay? So I can use this block for my new relay at 5 volt, okay? So I don't need it anymore, okay? So I can take this block away from here, okay? I can disconnect it and take it away from here. I finish with this as well. Okay. And now we're gonna go to check our relays we're using for our project. These are PCB relays, printed circuit board relays. Printed circuit board meaning they can either be directly soldered on a printed board, or if you make the prototype, which is always a good action, then you can put them over a breadboard, okay? So we're going to check several kinds of relays I prepared this one for. And now, let me find out which of them comes first to be checked. Okay, I'm gonna start with one which is apparently a simpler one, but it's very tricky. This one here in the bottom. This one here in the bottom, it has 1, 2, 3, 4, 5, 6 terminals. Is this guy here, this blue guy. It has 6 terminals. However, the temptation when you see such a thing is to say, oh, the 2 terminals which are very far from the others are the coil. It's a tricky thing, not true. If I'm going to measure between these two, I'm gonna find something very strange. Take a look. One leg here and the other one here. And I'm going to find 0 ohms. But when you take a look in the specs for that relay, what you're gonna find out, these are the 2 legs. So this is actually the common. There are 2 terminals for the common right here. This is why you see 0 ohms. It's not because it's normally closed contact. The normally closed contact is this guy here. And the other one is normally open. And the legs of the coil are real here between. So how can I check this? Take a look. I just connect carefully to the middle legs, and surprise, I'm gonna find something like 0.4 kilo ohms, which is 400 ohms. When you don't find 0 ohms, but you find a higher resistance, anything between 0 and 1 kilo ohm, something like this, hundreds of ohms, this is the coil, okay? So now, in order to not take guesses, you rather take a look in the specs, and this is the actual configuration of the relay. So I plug it right here, the relay, and what I devised for this little for this little, let's call it relay checker, is that I pick up my power supply, and by the way, this relay, I have to show it to you again, okay? This relay here, you can barely see it, is a 12-volt coil relay, 12-volt coil relay. It's written on the paper sheet from the manufacturer, 12-volt DC relay, okay? So before I energize anything, I adjust my power supply to 12-volt. Anything close is good enough, okay? And now I pick up the two legs. I put the negative in the bottom, anywhere on the bottom line. The positive in the top, anywhere in the top. And now, the relay is not energized yet, because in order to energize, I have to plug the second leg of the coil to the positive. But you can still see the red LED. Remember what we discussed when we made the diagram. Let's do this again. When the relay is not energized, through the normally closed contact in the common, you energize that red LED. So the red LED says what? Now I check my normally closed contact, okay? In the moment I'm gonna energize the relay, take a look what's gonna happen. You see the green relay, you see the green LED, okay? The green LED is why? Because when the coil is energized, now through the common and normally open, which closed now, you go here to see the green LED, okay? So that's how you check if the configuration for the contacts is the right one, okay? Not energized, energized. Not energized, energized. You see this? That's how you check it, okay? So this was a simple relay because you was only having a group of three, common, normally open, normally closed, okay? And now, I pick this one and I put it aside. And now we're going to play with another one. Actually, I want to show you something here because it's going to be the relay to be used for the project, actually. One of the two relays for the project. And is the one here in the middle. If you take a look on the internet and you look for this kind of relay, Songle SRC 05-volt DC SH, the letter H is not relevant because it's only saying what is the power the relay absorbs. You can have SL or SH. H, I think, is for 20 milliwatt power, and L for 36 milliwatt power is not relevant. However, if you look on the internet and you don't pay attention, that's the configuration you're going to find. Guess what? Is wrong. That configuration is not a good one. This is the good one. What is the difference? On the wrong configuration, they put the common here in the middle. It has two groups of contacts, top and bottom, and they put the common in the middle here. But actually, this relay doesn't have the common in the middle. It has the common right here. So when you're going to download the document, you're going to find out that I did this myself. I drew a line here, a red line, just to make sure that the poles you're going to see in red. So the pole is coming from here. And then you're going to have this configuration. You're going to have the common, normally closed, normally open. Common, normally closed, and normally open. And this one here, on the left side, is wrong. Okay? So I'm going to take a picture of this one and putting it on the Google Drive for you to download. Again, you go on the internet, and this is what you find almost everywhere. But if you go directly on the site of the manufacturer, Songle, and then you look for this particular kind of relay, you're going to find a good configuration. And now, let's find out. I'm telling you all this because you should be critical when evaluating the configuration for a relay. You don't take the things mechanically. You have to make sure that the configuration you have is the right one, because otherwise you try to use the relay and it won't work, okay? So I'm picking up one of such relays, and take a look what it says. This one is a 5-volt coil relay. What is my voltage right now is 12 volts, so I have to bring it back to 5. I'm repeating the same story all over again. You have to do two things. You have to always take a look and adjusting the power supply to the voltage the coil requires. And secondly, to take care about the configuration of the contacts for the relay. So for this one, if I connect it right here, I don't need the ohmmeter anymore, because everything I check now is through my diodes. Remember from the other one, I use a red one or an amber one for the normally closed contact and the green for the normally open, okay? So, in the moment, I'm going to connect my relay. Just give me a second, it's shifted. I think it's shifted one position. That's it. So now, this relay, as you can see it here on the configuration, it has two groups of contacts. So I have two normally closed ones, one in the bottom, one in the top. And that's what you see here. By picking up this red wire, I'm going to connect the coil over the positive. Take a look. Now you can check both normally open contacts, they close. And you can hear the click. I hope you can hear it. So the normally opens, they close, and this is where you see the green one. And why do you see the green one? Is because here the green one is connected over the normally open. And you see the red because the red is connected over the normally closed. So that's exactly the kind of diagram I'm respecting here, okay? So let's suppose you have a relay. That's a good one, not a problem. But you have a relay, you may have a doubt about that, okay? You're not sure if this relay is good or not good. So then you just plug it here. Okay, and when you do, you can check the two normally closed contacts are working fine. And when you are going to energize the coil, they do what? The normally open contacts, they close. The other ones, they open, you see? Anytime you energize the coil. Okay? So far, so good. And now, also for the project we're going to use together, the famous printer switch, you may need either this relay, and if you're lucky, that's going to be the simplest form of the project you're going to build, with two groups of contacts. But if the prototype is not going to work fine, then you're going to need one with 3 groups of contacts. Unfortunately, you can't find one with 3 groups of contacts, but I have one having 4 groups of contacts. So let me just show you the diagram. I have it over here. Okay, so is the one in the bottom here. So if you take a look, on one line it has 7 contacts. 1, 2, 3, 4, 5, 6, 7 contacts. So this relay actually has 14 contacts, which is which? You go in the specs, like I did, and that's exactly the type of the relay. I'm not discussing this one now in detail, it's gonna be for the next video, but the configuration is here. So somewhere in the middle is the coil, and you have 1 group, 2 groups, 3 groups, 4 groups of contacts, 3 each. Common, normally closed, normally open. Common, normally closed, normally open. It's written clearly here with big characters, and the relay has pin numbers everywhere, okay? So following exactly these pin numbers, I connected here 4 groups of diodes, okay? And just to save some space, instead of the resistors, I have network resistors to take less room. So now, I'm gonna check a bunch of relays I have here prepared, okay? Let's connect them here. By the way, these relays we're going to use because the interface we're building, the famous printer switch, works with USB, so 5 volt. This is why I'm still good with the voltage, is 5 volts, okay? So now what can you see? You can see 4 red lights. What do they mean? There are 4 groups of contacts, and all the 4 normally closed contacts are working fine. In the moment I'm going to just energize the relay, take a look. All the 4 groups of normally open contacts, they close, and the other ones, they open. So anytime I do this, so what is this diagram about? It's exactly this kind of diagram here multiplied 4 times, okay? That's all. And by doing this, you're gonna be able to check the relay. Don't ever connect the relays in a diagram before checking if they are working fine. Because otherwise, if they don't work fine and you solder everything, you may be in a big trouble, okay? So that's how you check. Let's say I have a doubt about the relay, okay? Not this one was good. But I have another one, take a look. These 2 ones, even made by the same manufacturer, okay? Aromat is the former name of the Panasonic division for relays. So this one and that one, they are not from the same lot, okay? For that reason, I want to check if this one is working well. So I connect it the same way. You don't connect the relays randomly. You connect it the same way as before. So take a look. My group of 4 LEDs is on. So all the normally closed contacts are on. And when I connect the power, I can see the group of 4 green lights going on at the same time. So the contacts of this relay are just fine together with the coil. You can hear the relay making noise. See? So now I pick it up and I do it one more time. I check another one, okay? So I have several relays here I ordered from eBay, and I can check all of them. This one also has 4 groups, same kind of relay, and I can check it in one quick move. It shows me clearly all the 4 groups are working fine. The last one, I still have one relay. Why not to check it, because we are here already. See, 4 groups of red lights, and when I energize the relay, everything is fine. That's how you check your relays. Thank you very much for watching. See you for the next one, guys.